If you think buying a modern hybrid means you're automatically saving up to 40% on your lifetime maintenance costs compared to a traditional gas car, you've swallowed the biggest lie the automotive industry has sold in the last 30 years. The suits in the glass boardrooms love to parade around their glossy brochures, talking about pristine efficiency and seamless green tech, but they conveniently leave out the grim reality waiting for you on the shop floor. I've spent nearly 3 decades with grease under my fingernails, tearing down powertrains and diagnosing electrical gremlins that the dealership technicians couldn't solve. And I am telling you right now that the system is hiding a massive financial ticking time bomb. The real stake isn't just a minor dip in fuel economy. It is a hidden, systemic vulnerability that can easily cost you over $4,000 in premature component failures before your odometer even clicks over to 6 figures. Why hasn't your service advisor mentioned this to you? Because the system thrives on your ignorance. They want you to believe that these hyper-complex electrified vehicles are magic black boxes that only a factory-trained technician with a proprietary scan tool can touch. They want you to feel powerless the moment a dashboard warning light illuminates. But the truth is, the fundamental laws of physics and mechanical wear don't change just because a manufacturer slaps an eco badge on the trunk. Underneath all that marketing hype, you're dealing with a high-stakes marriage of high-voltage electricity and internal combustion. And when that marriage goes sour, the owner is always the one who pays for the divorce. Let me give you a concrete example of what this looks like in the real world. Just last month, a fellow enthusiast rolled into my shop driving a highly popular, late-model hybrid SUV. On paper, this vehicle was supposed to be the pinnacle of reliability, a real golden goose of efficiency. The owner was a meticulous driver who followed the factory maintenance schedule to the absolute letter. Yet there he was, staring at a dashboard lit up like a Christmas tree, with the dealership quoting him an astronomical $4,500 to replace a corrupted power electronics assembly. The corporate diagnosis? Just standard wear and tear outside of the warranty period. But I don't just swap parts blindly. I investigate. When I pulled that integrated inverter unit apart on my workbench, the real culprit became staring at you obvious. It wasn't a catastrophic manufacturing flaw, and it wasn't a failure of the semiconductor chips. It was a completely preventable issue caused by microcavitation and thermal choking inside a cooling passage no wider than your pinky finger. The factory-recommended fluid change intervals were vastly too long for real-world driving conditions, allowing microscopic deposits to build up and create a thermal hotspot that slowly baked the internal circuitry. A simple $60 preventative flush, done at the right time, would have saved that driver thousands of dollars. But the manufacturer doesn't tell you to do that, because a dead hybrid component translates directly into a massive service department payday, or, better yet for them, a down payment on a brand new model. To really understand how we got to this point, you have to peel back the layers of how these systems actually operate on a physical level. The official story from the EPA and the marketing teams is that the gasoline engine and the electric motors work in perfect, effortless harmony. They paint this beautiful picture of energy flowing back and forth like a synchronized dance. Here is what they won't admit to you. That harmony is actually a constant, high-stress tug-of-war happening right beneath your floorboards. Think of your hybrid's high-voltage battery pack not as some infinite, futuristic power source, but simply as a bucket with a small hole in the bottom. The electric motor is constantly pouring energy into the bucket during braking, and the power electronics are violently ripping energy out of it every single time you step on the accelerator pedal to merge onto the highway. The electronic control unit, or the brain of the car, is constantly trying to balance this ledger on the fly. But over time, just like a human being facing constant stress, that control unit starts to adapt to bad habits. It reads subtle drops in battery cell efficiency and begins to overcompensate by leaning harder and harder on the internal combustion engine. This creates a vicious, hidden cycle. The gas engine is forced to fire up instantly when it is completely cold, revving to high RPMs to match the driver's power demand because the tired battery couldn't deliver the necessary punch. Imagine rolling out of bed in the dead of winter and immediately sprinting a 40-yard dash at full volume. That is exactly what you are asking your engine to do every single morning. This rapid thermal cycling creates extreme stress on the piston rings, the cylinder walls, and the head gaskets, leading to microscopic levels of oil consumption and premature wear that a standard laboratory test will never catch. But a technician sees on the magnetic drain plug at every single oil change. I have analyzed data logs across hundreds of these vehicles on the shop floor, and the patterns are undeniable. In vehicles where owners blindly trust the factory dashboard displays and the standard dealer recommendations, we see up to a 35% acceleration in internal engine wear and a measurable drop in true thermal efficiency by the time the vehicle hits its 5th year on the road. The vehicle might still run, it might still get you from point A to point B, but it is quietly consuming itself from the inside out while you smile at your fuel economy gauge. The system wants you to believe that this degradation is just an inevitable cost of driving an advanced vehicle, an unalterable tax you pay to the gods of modern engineering. They want you to remain passive consumers who just turn the key, drive, and write a fat check when the master warning light inevitably starts blinking. But I am here to tell you that you do not have to accept their timeline. You do not have to let their engineered obsolescence dictate the lifespan of your vehicle or the depth of your wallet. There is a precise, definitive set of rules to bypassing these systemic traps. A collection of shop floor secrets that can fundamentally alter how these complex powertrains age and ensure you never get taken for a ride by a predatory service department. We are going to expose the hidden vulnerabilities built into these systems, breaking down the exact mechanical failure points that the glossy brochures try to hide, and reveal the precise tactical adjustments you can make right now in your own garage to reclaim control over your machine. It all starts with a critical component that most owners don't even know exists: an unheralded gatekeeper buried deep within the chassis that controls the very lifeblood of the electric drive unit. And if this one specific piece of hardware gets clogged by even a millimeter of road debris, your entire high-voltage system will trigger a catastrophic thermal shutdown within 3 seconds. Flat. Here's the fix most dealers won't mention because it costs pennies in parts but permanently robs their service bays of a massive $4,000 repair bill. That unheralded gatekeeper I just warned you about is nothing more than the dedicated cooling fan and intake filter assembly for your high-voltage hybrid battery pack. In almost every major hybrid architecture on the road today, this intake is hidden inside the cabin, usually tucked right beneath the rear seat cushion or integrated into the plastic side trim of the passenger compartment. It is designed to draw ambient cabin air across the battery cells to keep them from overheating. But here is what the manufacturer's maintenance schedule fails to emphasize. That fan acts like a miniature vacuum cleaner, relentlessly inhaling pet dander, dust, lint, and road grit directly into the tightly packed cooling channels of your high-voltage pack. When those microscopic passageways get choked, the electronic brain doesn't immediately throw a code. Instead, it quietly throttles the battery's performance to protect the cells from thermal runaway, forcing your gas engine to work twice as hard and cooking the battery from the inside out. To stop this destruction in its tracks, you don't need a computer science degree or a multi-thousand-dollar diagnostic platform. You can permanently correct this design oversight in your own garage with basic hand tools, less than 1 hour of your time, and a total investment of under $25. Here is exactly how you execute this fix step by step to reclaim control over your vehicle's lifespan. First, locate the battery intake grill. In most standard hybrid sedans and crossovers, you will find this plastic slotted vent on the lower portion of the rear seat framework, or right next to the seat back bolster on the passenger side. Grab a plastic panel popping tool or a simple flathead screwdriver wrapped in a microfiber cloth so you don't scratch the interior trim. Gently pry around the edges of the plastic grill to release the factory retaining clips. Be patient here. Don't yank it, or you'll snap the brittle plastic tabs. Second, once the grill is free, you will likely see a thin mesh restriction layer, Or in older designs, absolutely nothing at all but raw fan blades coated in a thick, fuzzy blanket of gray lint. This is the exact moment where you install the real savior of your system, an aftermarket, high-efficiency particulate filter specifically designed for hybrid battery intakes. These are easily sourced online for $15 to $25. If your vehicle didn't come equipped with a replaceable element from the factory, these updated filter retrofits snap directly onto the back of the OEM plastic housing, blocking the fine debris that the factory grille allows to pass through completely unhindered. Third, look past the filter housing into the ductwork using a bright flashlight. You will see the scroll-type blower fan, often called a squirrel cage fan. If that fan wheel is packed with debris, its aerodynamic efficiency drops by up to 50%, drastically reducing cubic feet per minute airflow across your battery cells. Take a standard 10mm socket on a 1/4-inch drive ratchet and remove the 3 retaining bolts holding the fan housing to the chassis structure. Unplug the low-voltage wiring harness clip by pressing down firmly on the center tab. Fourth, pull the fan assembly completely out of the vehicle and place it on your workbench. Grab an old toothbrush and a can of electronics cleaner, or specialized compressed mass airflow sensor cleaner. Do not use heavy degreasers or harsh solvents, which can degrade the plastic blades or ruin the internal electric motor bearings. Carefully brush away the baked-on crust from every single individual curved blade, then blow out the residual dust with a can of compressed air until the wheel spins completely free and balanced. Fifth, reinstall the cleaned blower fan assembly. Torque the 10mm fasteners until they are snug. Don't over-tighten them into the sheet metal threads, and snap your newly filtered intake grill back into place. Mark your calendar to pull that snap-in filter element out every 12 months or 12,000 miles. You just wash it out in the sink with warm water, let it dry completely, and pop it right back in. Let me show you exactly what this simple maintenance habit accomplishes when applied on the shop floor. A regular customer of mine came into the shop with a high-mileage hybrid commuter vehicle that had clocked just over 140,000 miles. The local dealership had already diagnosed the car as needing a complete high-voltage battery replacement because the dashboard was triggering intermittent thermal degradation alerts. They wanted $6,000 for a remanufactured pack. Instead of writing that check, the owner brought it to me for a second opinion. I hooked up my data logger and went for a live test drive. Within 15 minutes of highway cruising, the internal battery temperature reading soared past 135 degrees Fahrenheit, forcing the computer to drop the state of charge window and run the internal combustion engine continuously at high idling speed. When we got back to the workshop, I popped the rear seat trim and pulled out a blower fan that looked like a bird's nest of pet hair and carpet fibers. We didn't spend $6,000. We spent exactly 45 minutes removing the fan, scrubbing the blades clean, retrofitting a high-density intake filter element, and performing a deep system reset via the low-voltage circuit. On the subsequent test drive, under identical ambient conditions, maximum battery temperatures never exceeded 104 degrees Fahrenheit. The battery cell voltages balanced out perfectly within 3 drive cycles because they finally had the airflow needed to shed heat. That was 2 years ago, and that exact same vehicle is still on the road today on its original factory battery pack, running flawlessly because the owner now spends 10 minutes a year checking a $20 filter. But you must be incredibly careful here, because there are a few massive, dangerous misconceptions surrounding this area of the vehicle that can completely destroy your hardware or land you in the emergency room if you aren't paying attention. The biggest mistake I see DIY enthusiasts make is confusing the low-voltage interior maintenance with high-voltage service. Under no circumstances are you to touch, probe, or attempt to disassemble the actual battery case itself or any bright orange wiring conduits you encounter near the fan ductwork. Those orange cables carry up to several hundred volts of direct current, which is more than enough to cause severe injury or instant electrocution. The cleaning and filtration process I just laid out is completely safe because it is performed strictly on the ambient air delivery side of the system. external to the sealed high-voltage enclosure. Furthermore, do not fall for the common internet myth that you can solve a battery cooling issue by simply turning your cabin air conditioning down to maximum low settings or using a standard household aerosol disinfectant spray into the intake vent while the car is running. Spraying liquid protectants or chemical mists directly into that intake grill will cause moisture to settle onto the high-speed fan motor, shorting out the control module instantly and sending a fault code straight to the master ECU that can lock your vehicle into an undrivable limp mode until an expensive electronic module is replaced. Stick to physical, mechanical cleaning and dry, high-efficiency filtration. By taking this one critical line of defense into your own hands, you aren't just cleaning a fan, you are actively altering the thermal dynamics of the entire powertrain. You are preventing the rapid battery degradation that the system counts on to force you back into the showroom every few years. But as vital as this cooling fix is for the electrical side of the equation, it only solves half of the hidden battle happening under your hood. The real mechanical carnage occurs when you transition back to the internal combustion engine, where a completely different engineered flaw is silently wiping out your fuel efficiency and varnishing your engine components from the day you drive off the lot. When you take control of your hybrid's thermal management and execute the precise maintenance steps we just walked through, you aren't simply performing a minor weekend chore. You are completely rewriting the longevity curve of your vehicle. By restoring maximum, unhindered airflow to that high-voltage pack, you immediately unlock a major cascade of real-world operational benefits that the dealership service department would prefer you never discover. First and foremost, you are going to see a definitive, measurable extension of your battery's operational lifespan, often pushing its reliable service life past 15 years and well beyond 250,000 miles without cell degradation, because the battery cells can now shed heat efficiently. The electronic control unit no longer needs to aggressively limit your state of charge window to prevent thermal damage. This means your vehicle can spend significantly more time operating in pure electric propulsion mode during daily stop-and-go driving, directly translating to a noticeable 5 to 8% bounce back in your true, real-world fuel economy. You will feel a crisper, more immediate throttle response off the line because the inverter can safely pull maximum amperage from the cool battery cells without triggering protective electronic power limits. But to truly solidify these gains and ensure your electrified powertrain remains bulletproof for the long haul, you need to layer this cooling fix with a few complementary advanced ownership habits. The very first habit you must establish involves a complete reassessment of your internal combustion engine's lubrication schedule. The manufacturer's manual will often claim that an ultra-thin 0W16 or 0W8 weight oil can safely stretch to a 10,000-mile drain interval. On the shop floor, we know that is absolute fairy tale marketing designed to lower the brand's fleet cost of ownership metrics on paper, because a hybrid engine undergoes brutal, constant thermal shock, frequently cycling from dead stop to high RPMs under load within seconds. The oil accumulates fuel dilution and moisture at a drastically accelerated rate compared to a conventional car. If you leave that ultra-thin oil in the crankcase for 10,000 miles, it shears down to the consistency of water, causing microscopic scoring on the cylinder walls and allowing carbon lacquer to varnish the variable valve timing actuators. Drop that interval down to a strict 5,000 miles or 6 months, and stick to a high-quality, full synthetic formula with a robust anti-wear additive package. That single adjustment prevents the engine from burning oil as it crosses the 100,000-mile threshold. Secondly, you must proactively manage the low-voltage auxiliary 12-volt battery, which is usually tucked away in a hidden corner of the trunk or under the rear floorboards. Most drivers don't realize that if this standard 12-volt battery degrades by even 20%, its internal resistance increases, forcing the high-voltage DC to DC converter to work overtime just to keep it charged. This creates a silent, continuous parasitic drag on your entire electrical system, subtly robbing you of fuel efficiency and causing bizarre, intermittent electronic glitches across your dashboard modules. Don't wait for the car to leave you stranded in a parking lot. Hook up a digital multimeter to that auxiliary battery during your seasonal tire rotations. If it reads anything less than 12.4 volts resting, replace it immediately with a premium absorbent glass mat cell. Now, as you optimize this system, you do need to be fully aware of certain physical trade-offs and operational realities. Some drivers think they can maximize their performance, and keeping the system primed by driving exclusively in sport or power mapping modes. While it is true that these modes sharpen throttle response and alter the regeneration curve under braking, they also instruct the computer to keep the internal combustion engine running almost continuously to maintain a higher baseline battery state of charge. If you leave the vehicle locked in these aggressive profiles for your standard daily commute, you are intentionally choosing to sacrifice up to 10% of your overall fuel economy and subjecting your mechanical valve train to unnecessary rotational stress. Use those performance mappings precisely when you need them, such as climbing steep mountain passes or merging into heavy highway traffic, but return the vehicle to standard or eco-routing modes for your everyday driving. Let the sophisticated algorithms do their job under optimal thermal conditions. Furthermore, expect to see a minor natural drop of about 5 to 10% in your total electric-only driving range during the extreme depths of winter. This isn't a failure of your maintenance or your cleaning habits. It is basic electrochemical physics. Cold lithium-ion cells natural to exhibit higher internal resistance, and the system is forced to run the gasoline engine more frequently just to generate cabin heat through the coolant loops. Do not panic when your dashboard range estimation dips in January. Simply maintain your intake filtration routine, and your maximum range will return the moment ambient temperatures soften in the spring. Look, at the end of the day, the entire automotive corporate structure is designed to keep you in a perpetual loop of dependency. They build incredibly advanced, highly capable machines, but then they purposely obscure the simple foundational maintenance realities required to keep those machines running indefinitely. They want you to feel intimidated by the orange cables. They want you to feel outclassed by the software. They want you to treat your vehicle like a disposable smartphone that you trade in every 36 months for a fresh lease payment. But the power has always belonged to the person holding the wrench. By understanding the true physical needs of your powertrain, by refusing to accept extended factory drain intervals and keeping that critical battery cooling circuit completely pristine, you are breaking out of their engineered cycle. You are ensuring that your hybrid remains what it was always truly meant to be, an absolute fortress of long-term efficiency and reliability that serves your wallet, not the dealership's bottom line. You have the knowledge, you know the exact failure points, and you have the steps to prevent them. Get out into your garage, check that filter, drop those oil intervals, and take back control of your machine.